I'm going to make a video today to talk about the different ways in which our software, the servo driver itself, can calculate the heat that's inside the scanner. This can be important for applications that are really driving the scanner very hard, such as medical imaging. In some cases, laser light show, if it's really scanning very fast and very wide at the same time, what we call high RMS content can heat up the scanner, and the software and the servo driver will really want to know the temperature inside the scanner. And the reason why is because we come over here to the Pangolin only tab. This tells the servo what to do at certain temperatures. And in this case, for this particular scanner, the way it's tuned, the servo driver will start taking action at 80C, and then it will completely turn off the servo driver and scanner at 100C. But in order for the servo driver to do this, it has to know the coil temperature. And the servo driver calculates this coil temperature in one of two ways. One way says here, calculated by RMS current driven into the scanner. And another way is this. It says calculate by actively measuring the coil resistance. Now I'm going to be talking about the differences between these two in this video. Now in most cases and for most clients, we choose this one. And the reason why is because if we know only these top few parameters here, coil resistance at 20C, you could ignore this one, and thermal resistance. And these come right off the data sheet. I'm going to go to scanners. This is a Saturn V system, and it is our standard coil configuration here. What we see is coil resistance 1.9, thermal resistance 0.9. We take this over to the servo driver. Coil resistance is 1.9, and remember this was 0.9, and it says 1.0 here. This is where you would make this higher if you know that your system as a whole, the XY driver, the XY mount, what the XY mount is sitting on, if your system as a whole isn't doing a really good job at sucking the heat off the scanner, you can raise this. And how this one calculates the heat inside the scanner is it takes the coil resistance, it takes the current, the RMS current that's driven into the scanner, it takes that and squares it. I squared multiplied by the resistance here, I squared R, and then that multiplied by the thermal resistance will tell our software and our system the heat inside the scanner. And this is kind of how it all works. Right now, this works well, and this is insensitive to the length of cable between the servo driver and the scanner. So some of our clients want to swap cables, want to do this and that, want to change things. And when it's in this setting, the entire system as a whole is completely insensitive. They can put a 50-meter cable onto the thing, and it will still accurately calculate the heat in the scanner. Because it's just simply I squared R. Now, here's where this system here, the reason why we have two different ways of calculating the coil temperature is because this is insensitive to the length of cable between the servo driver and the scanner, which is good. Insensitivity is good, but is unfortunately sensitive to how good of a job the end user has done at heat sinking the scanner. So for example, if a person takes the scanner, let's see if I can find the scanner here. If they take the scanner and they operate it in midair, not connected to any heat sink whatsoever, if they just operate it, if they've done a very bad job at seeking the heat from the scanner, then this setting here makes an assumption. The assumption is that the thermal resistance of the entire system is 1 degree C per watt. The scanner sitting here in midair is probably 50 degrees C per watt. So that's not, so if you use this method here, it will make a bad assumption and possibly allow the scanner to overheat. So that's where this one comes in. It says calculate by actively measuring the coil resistance. And in this case, it goes through a very sophisticated algorithm where it is constantly measuring both the voltage and the current across the scanner and doing some math to subtract off coil inductance and back EMF and everything else so that it can actually calculate the heat inside the scanner. Now the great news about this one is that this works. It doesn't matter. The person doesn't have to do a great job at sucking the heat off the scanner, because this will figure it out. And you'll notice that there's little graphs in here, this little line around here, and then this little line around here. And the way that these lines work is when you select this one, this is really the only parameter. This plus these is the only parameter that's needed. When you select this one, this parameter isn't even needed anymore because it's not used. And these three parameters are needed. Now, some of the stuff comes right off the data sheet. You know, the back EMF constant here, it says 62.8. The coil inductance says 130. And you can see here, this says 65 and 124. And the reason is because really every scanner is a little bit different. When we ship one of these systems, we actually measure it and we fill these in. You'll notice that this is the X scanner, and this is 0.22, 124, and 65. When I select the Y scanner, this is 0.20, 124, 65. And this is 2 ohms, because this scanner had a little bit higher coil resistance, whereas this is only 1.9. So every scanner is a little bit different. And the point is that when you use this method right here, calculate by actively measuring coil resistance, all kinds of things have got to be like really right on in order for it to do a good job. If all of these parameters, like this one, and these three are exactly right, this thing will really calculate the heat inside the scanner very, very accurately. But if they're wrong, it won't. And so that's why for most clients, we select this one here, because for most clients, we only have to get a couple things right, and as long as you use our XY mount and mount it to a good system, this will do a good job. When we don't know how good of a job our clients are going to do at heat sinking the scanner, when we do the scanner tuning, we choose this one, and we will set these parameters up exactly correctly. So this video here, I'm going to be talking about the difference between these two, and how to set it and how to change the parameters if you go from a short coil to or a short cable from the servo driver to a scanner to a long cable from a servo driver to a scanner. So what I'm going to do is I'm going to come back here, select activate scanner number 2, tuning number 2, because I've been doing all kinds of fun stuff with this thing and messing around before I even started the video. So in this case, tuning number 2, it's a 30K tuning, and just like I said, we normally ship it with this one here selected and these parameters input. This is selected, right, on both of them. So so what I'm going to do is I'm going to open up the function generator here. I'm going to say 60 hertz. This is great. Square wave in phase. Make sure to check that. And then say 10 degrees. So now this system is putting out a 10 degree 60 hertz square wave on both the X and the Y axis, and it's in phase. And we can see that the heat inside the scanner right now, the coil temperature, is 33.36 degrees, roughly for both of them. So now, if I select this one, I'm on the X axis, you'll notice all of a sudden, now this changes a little bit. So this is a little bit more accurate. Now, on this X axis, I happen to have a 10-inch cable like we usually ship, right? But on the Y axis, the cable I have is a 3-meter cable. And the purpose of this video is to show what you need to change if you change the cable and if we actively select this. So you see now we're sitting here at 33 degrees, right? And remember I said that this is completely insensitive to cable length. Well, if I click on this one, all of a sudden this thing thinks that the coil that the temperature in the scanner is almost 50 C. And the reason is because a 3-meter cable has a lot more resistance in it. And what's happening here is that you see this starting to give some phantom indication that it's really warming up. What's happening here is that the additional resistance of the cable, which is not being taken into consideration right now, is fooling the servo driver into thinking that that additional resistance was really coming from the scanner coil, which means that it's hotter. So what we need to do if we increase the cable length is increase this coil sense plus cable resistance from 0.2, and all I'm going to do is keep on clicking up and up and up and up, and as I click up and up and there, you'll notice that this is coming down and down. So I'm just going to click up and up and up and up and up until this gives us a believable value, right? And so it's starting to match this one now. So it's believable that the previous cable resistance was 0.2 ohms and the new cable resistance is 0.36 ohms. And so now we can save this as part of the scanner tuning because we have adjusted this to that the servo driver now understands that you got a longer cable here. The servo driver is just going to take that into consideration. So what we can do now is, after we have adjusted this at 60 hertz and 10 degrees, which is a great frequency to exercise the scanners with for the purpose of this, you say, make sure you say square wave in phase, and then set this to 0 again, which will allow normal input to come in. See, it says 0.0 because external. That's what we want. And then we come up here and say tuning, save to tuning number, whatever that says. I'm on tuning number 2 right now. I'm going to save this to tuning number 2. It asks us, am I sure? Yes, I'm sure. Now, you have to do this for every tuning that you want to use. May as well just do it for every tuning. So what I'm going to do once again, so once we know this number, 0.36, we can just do it to the other tunings. So I would say activate tuning number 1. On the y-axis here, I'm going to type this to 0.36, okay, and then tuning, save to tuning number 1. Yes, I'm sure. And then we'll go over here to tuning number 3, since I started on tuning number 2. And once again, I'm on the y-axis, come down here, just type 0.36. And then tuning, save to tuning number 3. Am I sure? Yes, I'm sure. Yep. And so you do this for all the tunings, don't forget. Otherwise, someday somebody might choose a different tuning number where you didn't do this, and just some confusion might result. So so now here's a situation that might arise. So once again, I'm going to do the exercise again. 60 hertz. Let's say 10 degrees, and let's go back here. And now see, we say, okay, here's the coil resistance, and let's say I had this wrong, and I've gone from a 10-inch cable to a 10-meter cable, and let's further assume that we go from a 10-inch cable to a 10, and because the resistance, the wire we use in our cables is really super thick wire. Let's see, where is it? Here it is. I mean, it's really thick, and we have 4 strands of this really thick wire, and that's why our cables have just such low resistance. If you replace our cable with this really thick wire with a long cable that has really thin wire, it could be that this will go up quite a bit. So I'm going to do this one more time to illustrate something. I'm going to click on this, calculate, and you'll notice that this goes really high, right? Well, what could happen is that this thing goes so high that it actually shuts down the servo. Like, I know I'm lowering this, but I'm just illustrating a concept. It could be that this goes so high when you put that 10 or 20 meter cable on there, a crappy cable, that this thing goes so high that it eventually trips out these values here, and it just shuts down the servo to protect the scanner. So the way to do that will be like this. You start off in this mode, in which case the servo will be fine. You can put any cable you want on it, it won't matter. And go ahead and just adjust this. Go ahead and increase it. I could set this up to 0.33, let's say, and then I'll click this button and watch this and say, okay, well, is it close? Okay, yep, it's getting closer. So I'll go back into this mode and increment this, let's say to there, and then I'll go back into this mode and say, okay, is that better? Is that looking better? Okay, perhaps. So you can come back in here, you can increase this, and then come back in here and watch this temperature until it gets to something reasonable, until it gets to something that you know where it is. You can do that. Now, you would only need to do this kind of back and forth thing if you go from one of our super duper well-made short cables to a super duper long crappy cable. You'd only need to do this back and forth if you do that. Otherwise, normally you could just kind of hang in here and then just change the cable and then increment this as needed to get the temperature looking reasonable. And don't forget that once you're done, to save the tuning, right? Because these parameters are not, say, you could adjust them all you want, and then they're just going to bounce right back as soon as the servo, either somebody does this or the servo is repowered. Because once the servo driver power is applied, and that's when it reads all the things out of the tuning. So you can adjust them all you want, but it's not going to matter until you actually save it into a tuning, right? So I hope this is helpful at explaining what to do when you increase the cable length beyond what we supplied with the system. You will definitely need to adjust this parameter, especially if you want to operate in this mode. Not all of our scanners can operate in this mode. The Compact 506 cannot even operate in this mode at all, ever, because of the magnetic circuit in it. And so the Compact 506 can only operate in this mode. But our Saturn series can operate in this mode right here. ARC probably can operate in this mode. Sometimes I use ARC scanners in this mode. And so just make sure that this is selected, make sure these parameters are correct, and if it's shipped from us, these parameters will be correct, and then you can adjust this current sense plus cable resistance to match what you have. And you'll know what you have because these values will be correct. And then from that point forward, as you're operating your system, you can from time to time take a look at these and just see how hot the scanner is getting while you're operating the scanners in your application. So thanks.